Okay, so this is the 2019 paper 2 question 4 on logarithms. Right, so they tell you solve this equation. First thing to take note is the bases are different. So we always want to change the base to be the same. Well, what base to change? We always want to make it smaller. So we're going to change this base 16 into likely base 2 lah, so that we can get all our values to be the same base. So I'm going to change it, right? Log base 2 x stays the same. This becomes log base 2 because that's what we want. I'm going to shift the x up. I'm going to shift the 16 down, right? So that's how you change your base, right? Log base 2x on the top. The bottom becomes log base 2 16. Okay, we also know that 16 is also 2 to the power of 4. So I'm just going to write here, instead of writing 16, immediately 2 to the power of 4. And this is equals to negative 2.5. Afterwards, I'm going to bring this power down, right? You will be able to see that this whole term, right? Because you need to know that log 2 is just equals to 1. Okay, what do I mean by log 2? I'm going to shift this 4 down, right? Inside, I get it to be log base 2, right? Log base 2 is the same as 1. So this thing just becomes basically 4 at your denominator, equals to negative 2.5. After this step, well, I'm going to multiply everything by 4, right? Because I want to get rid of this denominator. So I multiply everything by 4. Here will also have 4. I multiply the whole thing. Multiply by the whole thing. Here I get it to be 4 log base 2 x plus log base 2x equals to negative 10. Right, over here I can bring my power up, right? I can basically get it to be log base 2x to the power of 4 plus log base 2x is equals to negative 10, right? And over here, what I'm going to do is I'm just going to combine these two together, right? You can use a combine rule, right? Because they have the same base, you can combine them together. In the end, they become multiply, right? The inside x to the power of 4 multiplied by x. I basically get this to be log base 2 x to the power of 5 equals to negative 10. Okay, simplify this some more. I'm just going to bring these two up, right? Because logarithms, remember, is just another way to represent powers. So logarithm of x to the power of 5 is equals to negative 10, right? And this is basically the same as saying x to the power of 5 is equals to base 2 to the power of negative 10. And over here, I have power 5, so I need to fifth root on both sides, right? To get my x value. When I fifth root, it is the same as multiplying 1 over 5, right? So you just press this in your calculator to the power of negative 10 to the power of 1 over 5. You will get your answer to be just 1/4. And that is your answer for your x value. Okay, so that's how you do part A. Just change base, right? Change base over here, recognizing that your numbers can be simplified, right? And then after just using your CC combine rule, right? And then bringing up your power to eventually solve for x. Okay, the next one they tell you it is given that log z minus log y is equals to log z plus y. Okay, express z in terms of y. Well, over here you can see that on the left hand side you can actually just combine them together, right, using our combine rule. Because it's minus, my logarithm functions will just divide to give me z over y. This is on the left hand side, is equals to log z plus y. After this, by comparing, right, comparing my left side and my right side, I can say by comparison, okay, z over y is equals to z plus y. Okay, make sure you write this properly. Z, not 2, right? And I want to make z in terms of x, so I want to make z the subject. Right, here you just cross multiply. Right, we bring all the z terms to the same side. Right, I factorize out the z. This is just your making of subject from EMATH. And I basically get my z to be equals to y squared over 1 minus y. Okay, so this is your answer for part B1. Okay, then the last part they tell you, state the range of values of z and clearly explain why y is greater than 0 and that of y is less than 1. Right? Let's see, they are telling you that y must be within this range, and we need to find the range of values of z. For z is more than 0 and and y is more than 0, right? These two conditions have to be satisfied first. Okay, why do these two conditions have to be satisfied? If we look at our equation over here, right, our z and my y value both needs to be greater than 0, because if not, my logarithm functions becomes undefined, right? So now that I can see that, right, we can also then conclude that, well, my y square value is also going to be more than 0, right? Why am I looking at y square? Because we actually just made z the subject, and if we take note, z is equals to y square over 1 minus y, right? We need to be ensuring that my z value at the end of the day is going to be greater than that of 0, right? Because of the restrictions of my logarithm functions up here, right? So I need to make sure that z is more than 0, so I need to make sure that from here I can also tell them that y square is also more than 0, because y is already more than 0, right? So you square any number, is also going to be more than 0. And over here, in order for this term to be more than 0, right, we have a positive term on the top, right? This is the positive term at the top. We also need a positive term at the bottom for this to be more than 0. And this positive term at the bottom needs to be that of 1 minus y to be also be more than 0, right? Because this is my numerator, this is my y square. Now I also need my denominator, which is my 1 minus y, to be also greater than 0. And as such, when I rearrange it, I get negative y is greater than negative 1. And y must be less than 1. So here we can see that, okay, we have y is less than 1, so that my denominator can be greater than 0. And at the same time, my y also needs to be greater than 0 because of the restriction of my logarithm function. And therefore, we can conclude that since y has to be more than 0, this is for log y, right? And y has to be less than 1 for 1 minus y to be more than 0. We can conclude that, therefore, y has to be greater than 0 but less than 1. And as such, we have proven. Okay, so we have also told them the range of value of our range of value of our z, which is basically z has to be more than 0 as well. Okay, so this is how you do the question 4 for your logarithm topic. Okay, the proving is a bit tricky, but so long as you can see the relationships in your logarithms and eventually explain to them from your making of subject, you will be able to find that out and prove this inequality. Okay, so that's all.